Hi guys! Today we are gonna discuss about the functional safety or ISO 26262. It's an overview session which covers the ASIL determination and even the basics of ISO 26262. Let us get into the topic. So what is safety, functional safety, and how is it plays a major role? Because the car or the automotive involves the human lives, so there is a risk of lives of the passengers and even the driver and even the passengers also. So if the automotive met with an accident, so it may also lead to the fractures or the lifetime impairments also, and even it will lead to the minor injuries, and the vehicle also will get damage which leads to the loss of money. So based on the on these all aspects, so and there is a future challenge like in technical aspects as well, like we are going ahead in terms of driverless cars and assisted cruise control. These all things, if it comes into picture, then we need to take care of the safety aspects. So what is safety in detail? So if you are planning for your organization to get 26262 certification, so what are the steps it involves? So we have categorized it into 5 steps. So first thing is like you being a supplier to the OEM. So first of all, you need to think like, how to start the FUSA journey. Then you have to hire a FUSA consultant, and based on his or her inputs, like you have to develop the entire safety documents like DIA, functional safety plan, and how you're gonna address the functional safety challenges in your organization. And you have to give trainings. This is step 3. You have to give trainings or the workshops which we have to conduct on the safety documents whatever we have prepared to implement the functional safety in our organization. And then we have to develop a functional safety life cycle, as that is a step 4, and we have to implement it in a selected product, and we have to get it certified that it is FUSA compliant product. So as V model is famous in the automotive, so this is the in safety also we have a V model for the product development. So first thing is a concept development. Here we will develop the safety item development or the hazard and risk analysis. So based on the hazard and risk analysis or HARA, so we will find out the ASIL level of the product. So we will get into more details in the further slides. So how to determine this ASIL levels for your product. So after concept development, we will come across the system safety architecture definition, and then hardware and software safety analysis. So which deals with FMEA, FTA, low level design as well, and then design implementation. This is ISO compliant design implementation, and the testing is unit testing, integration testing, and even functional testing, and the system integration and integration testing as well, and safety assessment and validation. So this is the safety confirmation review, like that this particular product is compliant to the ASIL safety compliant or something like that, like this is conducted by third party assessors. So what is the difference between any other automotive standards to this functional safety? So in functional safety we will have, we have another, there are 4 different levels of ASILS. So we have based on the ASIL levels, like we have to define our product. So some of the activities which are mandated, which are highly recommended to the levels, ASIL levels. So what is ASIL? ASIL is Automotive Safety Integrity level. So SLA is the lowest and SLD is the highest. So SLA, SLB, SLC, SLD. So SLB is moderately low, SLC is moderately high. So I tried to represent it in the particular way, but wherein we have another category called QM, it is quality management level, which is lesser than SLA level. SLA is very similar to QM, which involves a less risks associated with it. So the QM artifacts are very similar to the, if you have ASPICE level 3 compliant product, then you are almost QM compliant product. So determining ASIL levels. So how do we determine ASIL levels is through HARA, hazard analysis and risk analysis process. So as you know, like all the components of the car, of the vehicle is not involved in equal threat. So if the fault in a particular component may or may not lead to the failure of the entire system. So how much is the probability, how much is the severity, how much is the controllability? Based on all these aspects, we will come up with an analysis called HARA, and based on that, like, we will find out the ASIL levels. So what is hazard? Hazard analysis identifies the unintended situation that could occur in time of failure. Risk analysis deals with three different things, that is the possibility, that is the probability, severity and controllability. These three involve. So let us get into the details of it. What is the probability of exposure, and what is severity, and what is controllability? So what is exposure, or the probability of occurrence of the fault in the component? So it is categorized further into three different levels, that is E1, E2, E3. So E1 is the lowest possible, and E3 is the medium possible, and E4 is the highest possibility. So wherein severity, we have three different categories. What is severity? Is the intensity of the damage and its impact on the vehicle and its occupants, like whoever is sitting in the car. So there are three different levels, S1, S2, S3. So based on the severity of the injuries, S1 is light injuries, S2 is severe injuries, S3 is life-threatening incidents. So third category is controllability. It is ease of controlling the vehicle by the driver in case of fault or malfunction. So C1 is easy to control, C2 is moderately difficult to control, C3 is difficult to control. So this is the ASIL determination matrix. So we have three different categories here. So this is severity class. As I said, the probability class here. So probability of exposure is four different categories. So E1, E2, E3, E4, and severity class is S1, S2, S3, and controllability class is S2, C1, C2, C3. So based on all these three combinations, we will get the ASIL levels. So QM, as we said, quality management. So this all QM is less impacted product. So when do you get the SLD is when severity is S3, exposure is E4, and controllability is C3, then you will get D. So let us get into another example. So if I see this, okay, this example of SLB. When do we get SLB? Is S1 is the severity, E4 is the probability of exposure, and C3 is the controllability, then you will get B. So you got this, right? So how we will determine the ASIL levels. Similarly, in 61508 also we have SIL levels, that safety integrity levels is also like level 1, level 2, level 3 will be there. But it is two-dimensional, means like only two different things will be there. But this particular matrix is three-dimensional, or yes. And we can move to the ASIL examples. So before we have discussed like what is QM, what is A, what is B, what is C, what is D. Okay, these all combinations we have looked in the matrix. So wherein these are the different subsystems or systems which are involved in the automotive vehicle, or automotive or the vehicle. So it's like for me, or a car is a system of systems. So wherein like you will have the airbag as a system, you will have engine management as a system, headlights as a system, radar cruise control as a system, electric power steering is a system, vision ADAS is a system, active suspension is a system, anti-lock braking is a system. So these are all the systems. So what is the criticality which involves in it, or the ASIL levels involved is, for example, if you see this anti-lock braking, unintended full power braking. This is the failure. This is the statement of failure. So which leads to ASIL level D. Okay. And if you look at the brake lights, so both side failure, both side brake lights, if it is failed, then ASIL B. How it is possible, like nobody will get to know, like you have applied a brake and there is a possibility of an accident, right? So this similarly, these are all the examples. So let me get into the another pictures which is similar to this. So this is another picture I got from the internet, like these all the classifications, ASIL level classifications and the different systems, so which involves the ASIL level determination. So we have come up with vision ADAS, so incorrect sensor feedback. So if without an obstacle in before ahead, so if the sensor detects a wrong obstacle, so all of a sudden the vehicle will stop, but without an obstacle. So which may also lead a collision, but the probability of that collision is very less. So based on that, it is SLA. So what is ASIL summary? So this ASIL summary is it's like it is a fault in a component which leads to the failure of the entire system, so which may risk the driver or passenger's life. So here I want to discuss about this from IEC 61508. We have derived this ISO 26262, which is defined in particular for the electrical and electronic components of a road vehicle. So how do we determine is like we will determine probability of exposure in terms of E1, E2, E3, E4, controllability in terms of C1, C2, C3, and severity of the outcome of the fault, means like S1, S2, S3. So all three together we will keep it in a matrix and we will find out the ASIL level. So every time when you are finding out an ASIL level, it is highly recommended that you have to start it before developing the product. So if we do it in the beginning, then you can be able to prepare everything based on the ASIL level. So there are so many aspects like which are depending on the ASIL level and the recommendations based on the ASIL level. So that is the reason. So in the initial time of the product, if you determine the ASIL level, then it would be good. So it will avoid a lot of rework. So sometimes like in between also in between the product development also, the ASIL level is determined, but wherein like you will end up with a lot of rework, so to get in adhered to the requirements of that particular ASIL level. So it is always recommended to determine ASIL level at the beginning of the product. So here are some abbreviations, so which I brought here. So there is FUSA is functional safety, HARA is hazard analysis and risk analysis, FMEA is failure mode and effect analysis, DIA is development interface agreement, SPFM is single point fault metric, LFM is latent fault metric. So I have come up with these all things, so just to keep everything together. Similarly, these all ASIL, AUTOSAR, CCF, CF, CMF, DC, DF, DFA, these all abbreviations. So I think four pages I have made. So whatever the abbreviation, I think I have covered most of the abbreviations which we face through FUSA development. You can have a look at this: DTI, EMI, EOS, ESD. I have tried to put everything in a chronological order. Yes, that's it. SEOC, SET, SEU, TCL, TD, TI. All these things. So what are the other things like which is similar to our ISO 26262? We have the prominent things which are similar to this 26262 is 61508. IEC 61508 is for electronics. IEC 62304 is for medical devices. As we have ISO 26262 ASIL levels 1 at A, B, C, D, we have similarly 6150508 we have SIL 1, SIL 2, SIL 3, level 1, level 2, level 3, and even for 62304 or 62304 for medical devices we have A, B, C categories based on the criticality of the medical devices or the cause. Like for example, if something is involved with laser, so which may damage the organs, so that may term as C. It may cause a serious injury or harm or the seizure sometimes. So this based on this I gave up because we have a similar set of standards. So let us get into the similar standards, which is see IEC 61508 is the first standard which is defined for the electronics. So from that we have derived these many specific department oriented or the oriented standards. So ISO 26262 we have developed for automotive, IEC 61513 for nuclear sector, EN 50128 for railway applications, IEC 61511 for process industry, D0178 and D0254 is for avionics. Machinery we have ISO 13849. Medical we have IEC 60601. Home we have IEC 60730. For machinery we have IEC 62061. For variable speed drives, so we have IEC 61800 part 5 section 2. Programmable controllers we have IEC 61131 part 6. So a part of this thing I have not covered furnaces. In the second diagram we have IEC 50156. So this is another representation of safety life cycle. So we have phase 0 to phase 7. So that means which involves 8 different phases. So first thing is hazard analysis and risk analysis, so or the risk assessment as the first one, and the safety planning, and this is derived from 61508. IEC 61508 for SIL 1, SIL 2, SIL 3 levels. So that is the reason, so it is mentioned in this particular way. Safety planning, specification, validation planning, realization, verification, code simulation and validation. So code simulation is very prominent in case of safety because in any manufacturing industry, so we will have multiple levels of sampling which will come across the to define or to evaluate the design or the implementation of the product, so which involves a lot of cost and which involves a lot of wastage in the mechanical designing and all. So simulation plays a major role because which involves, so we will replicate the entire entire product and we will try to test the product in the simulation world itself, so which saves a lot of money, which helps us in identifying. See, you may not operate the same physical device in certain way. So if you have a simulated environment, so you can test the product in 100 different ways with the same simulated code. So here is a sample which I brought from the internet. So this is the example from ABS system. So ABS is anti-braking system. So what happens if the ABS fails? So hazard analysis says like what unintended situations or hazards could happen. So loss of stability on split mu surface. risk analysis involves, so as I said, three different things: exposure severity and controllability. So what is the probability of exposure? So if the surface has oil spill or gravel or water potholes, so that's when the exposure increases. So the probability of exposure level increases. So how harmful is the hazard is the severity. A car may spin out of control and crash. How controllable is the system? If the hazard occur is controllability, it is dashboard or driver. So how much we can able to control, and based on this ASIL determination we can do. So what level of safety does the system need? That means how we can reduce the risk, reduce the impact of the failure. So this is nothing but this is the try we are making in while implementing the safety standards. So how likely can the malfunction be? So that is a failure rate, and how to mitigate the failure rate. So that's how it is. And how often does the system needs to catch it and get to the safe situation? So effectiveness of failure detection. So we have multiple combinations of failures. So based on SPFM and LFM, we will determine the effectiveness of the failure detection. So this is the overview of the ISO 26262. Here I have covered ASIL determination and even a few abbreviations and what are the similar standards of ISO 26262 also I have covered. Thank you so much for watching. Thank you so much for your time. If you like this video, kindly like, or if you want further automotive related videos, kindly subscribe to my channel. Thank you.